So inshallah, this chapter 8, the
Doctor,
periodic relationship among the elements. I will start this now. Yes.
for me, the experiment one with Dr. Ali, and you said you'll talk with him.
No, no, I already talked to him, but you are the student of him. You should tell him, my teacher will give me 0 if you will not send the report.
He didn't
This is your
respond. I
responsibility,
talked
not
to
mine.
him in email and WhatsApp, and
Go to, write to the chairman. My teacher is not listening to me. Okay? Write to the
okay,
chairman. Sir,
okay,
Dr. Ali, I have sent, give the proof. I have sent this
okay,
email, I have sent this message, and he did not reply me because the 2 labs he has, and now the section has been changed to Dr. Ali Tariq. He will give me 0.
okay, okay,
Please help me in this regard because I already spoke to him. If he is not sending, I'm sorry for that. I will give you 0 in that lab. I'm telling you now. If he will not
okay,
send.
doctor. Okay,
Please help me. Those students who were with Dr. Ali, please, you should contact yourself to you. That was your teacher. If you have any problem with me, you tell me. I will resolve that. Okay, so the relationship among the elements, it will cover 8.2 to 8.5. And this, if you remember that in chapter 7, I already explained the arrangement of configuration, how to write the configuration of any atom or any elements, right, in the periodic table. You remember this? 1s, 2s, 3s, 4s, 5s, then 2p start from always from second shell, and this the 3d start always from the fourth shell, and 5f start always from the sixth shell, and 5f from the seventh shell. So this you should know that this you can answer the following the multiple choice question like that. And the electronic configuration, how to write the short configuration and long configuration, I already explained you. Did you remember anybody? The difference between short configuration and long configuration, and what is the concept for short configuration? How to write?
In short configurations, we use the noble gas like
Yes.
neon.
Yeah, previous. If your element is in the shell 3, so you have to look shell 2 noble gas in the previous shell. Clear? If you have element in the periodic table in shell 4, so you have to look shell 3. In the shell 3, what noble gas is there? So you have to use that configuration as a short electronic configuration. And in the last, you have to write the specific characteristic configuration of that element. If suppose it is this element is in the first group, second group, so the first group start finish 1s1, the second group configuration finish by 2s2, and the non-metals they will start p1, p2, p3, p4, p5. So that will finish by p orbital. If any element in the d orbital, that electronic configuration finish by d orbital. So you can identify in this way which element belongs to which metal or non-metal or which group. So that is S, P, D, F. These are the groups you can easily identify. So this the first, the 1A, this noble incomplete, that is the representative element, means noble gas, not noble gas only, all the non-metals on the right side from 1A to the 7A, NS2, NP6, these are the general information, yeah, of the, octet is complete, right? And now how this octet is complete in 8A, halogen, noble gas, halogen up to here, 7A. So that is NP5 here. Okay, NP5 incomplete. When octet is complete, it become Np6, that is noble gas. Transition metal start from 1b and 3b and through 8b, that is a transition metal, and you remember transition metal only in your course, the first row. Scandium to zinc, that is only the first row in transition metal, look at that only. F blocks are not in your course, okay? And the valence electron, this is general information, I already explained you what are the valence shell and what are the valence electron. The valence shell is the last shell in an atom. That is known as valence shell. Alright, I will explain here again. Valence shell, that is last shell in an atom. Valence electron, the electron present in the last shell or valence shell, that is known as valence electron. Example, and you take carbon C6H12, 1s2, 2s2, 2p, 2p2, right? So you can write here, there is a 1s2, then second shell, 2 electron, and 2p. So 2p and second shell coming both 2p and 2s. So there are, the last shell is this one. So don't say this is only last shell. No, you have to see the last shell is 2 too. So this is the last shell. And the electron, how many? 4 electrons are present in the last shell. 4 electrons are present in the last shell. Present in the last shell is known as valence shell. Is this clear to you?
Yes, teacher. This is clear.
Yeah. Anybody which is not clear, then I will give another example. You can write yourself. That is example is oxygen. So you can write oxygen. That is a 2 electron, 1s2, second 2s2, and 2p, 8 electron, right? 4, 4, 8, 2p4, right? So 4, 2 plus 6, 1, 2, 3, 4, 5, 6. So these are the valence electron. So valence electron is equal to 6 electron and 2 electron inside, because this is second shell. So in the second shell you will get 2s and 2p. In the first shell only you have 1s. These are the periodic table, as I told you. The first and second, these are the representative element from here to here. The purple color, this is a representative element. Group 1, group 2, then group 3, 4, 5, 6, 7, 8. These all are representative. But in this representative on the right side, in this representative element on the right side, there are some metals also here. These are the metal. But this boron is not metal. This is metalloid. This is metalloid. Okay, metalloid, metalloid, right? Metalloid, 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 metalloid. So you can see in the book, There's a pink color. There is a metalloid is written here anywhere? No, because this is not exactly pink color you will get, but here pink color is actinide, lanthanide, but these are not in your course. Only noble gas, representative element, and transition metal. Only this first series I already explained you. So you will go through the book, you can check, or any other periodic table, you will find the here pink color you will get from here to here. These are the metalloid. This is the noble gas. Noble gas. This is halogen. Alright, these are carbon, nitrogen, these all are non-metals. Alright, but these are metals. Lead, indium, gallium, these are metal. Alright, metal. So this go through this, right, and you can identify and can easily answer any. Once you are strong in the periodic table, you can answer easily. See, alkali metal, first group, as I explained you, the first group designated by NS1, second group by NS2, the third group is this is fourth group, right? So fourth group, the last, whatever the valence electron, that is its group. If fourth group, 4 valence electron. If one group, 1 valence electron. Second group, 2 valence electron. Similarly, charge. First group, 1 plus charge. Second group, 2 plus charge. Third group, 3 plus charge. Fourth group, it has 2 charges, plus 2 and minus 2, no sorry, plus 4 and minus 4 start from carbon. Remember that. Then reducing order, all this negative charge because they complete their octet by gaining electron. Metal always release electron, not gaining. So from carbon to halogen and noble gas, minus 4, minus 3, minus 2, minus 1 halogen and 0 noble gas. Alright, so now this carbon is a non-metal, silicon, germanium are the metalloids. See, these are the metalloid, but this why we call it metalloid? This because they use in industry. Which industry? In electronic industry. Germanium or silicon chips they are putting into mobile and laptop. And tin and lead, these are the metal, as I already explained. Noble gases, just noble gases, all this here, but some noble gas, only this xenon, only xenon form compound with oxygen and fluorine. That's ZiF4 and ZiF2. Actually, these are reactive than other noble gases. As I told you, the noble gas cannot be react with any metal and non-metal because of octet is complete. But the xenon, it has, because the xenon has less ionization energy, so means that it's very difficult to ionize any electron from there, so it can make compounds. It can gain, react with other non-metals, so they will make compounds. So this can be asked any multiple choice question: which of the following noble gas react with fluorine or oxygen as compared to other noble gases? So you should write the note, please. Any question now?
So only the xenon?
Only xenon.
Okay.
So this is all about, see, I already explained a general formula: NS1, NS2, 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 NP1, NS2, NP2, the p orbital start, right, and the d orbital start from d1 to d10. All right. Okay, suppose the question is giving to you certain element has only 15 electrons. So don't look at the periodic table. Without periodic table, you have to answer these 3 questions. What is the ground state electronic configuration of the element? Ground state is simple electronic configuration, nothing changed. No excitement of the electron, as whatever I told you, simple 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, something like this. Simple configuration. So you can write either short configuration or long configuration, it doesn't matter. Second, how should the element be classified? Now only electrons are given to you, and when you write down the first electronic configuration, then you have to look the last shell as well as subshell. So according to the last shell and subshell, you identify element. Is the element diamagnetic or paramagnetic? I already explained you in chapter 7. Diamagnetic, you have to write the block, and you have to fit electron inside according to the rule. If they are paired, that is diamagnetic. If even single electron is parallel only, not paired, so that is paramagnetic. So now suppose the 15 electrons. So now how we write 15 electron? This is only the way we have to write here. Ground state 15 electron, 1s2, 2s2, 2p6, 3s2, 3p. How many now? 6 for 10, 12, and now 3. So we have to write 3 here, right? So now you have to look this one. What is the shell? This is the shell is third. Third is the shell. So you go to third shell. Then you go to the p level, not s, not d, p level, p orbitals. That is, either you can say orbital or you can say shell, subshell. So that is 3. So you just go to third shell and then you go to 3p. Then you will find this element should be here. And that element is phosphorus. You can check your periodic table. Is it clear now? Hello? Is it
Yes.
clear how to identify, how to write? Identify the phosphorus you identify and you write down this 3p3. So now you have to change this one, 1s2, 2s2, 2p6, 3s2. Now this one, say 3p3. So this we have to write, fill all box with single electron, right? And now you have to fill like this. This is already complete. Right, like this. So it means that, is it paramagnetic or diamagnetic? Hello?
Paramagnetic.
Yeah, diamagnetic is this and paramagnetic is this, parallel. So in this way you identify without looking predictable. Then here you can look predictable here, which shell and which subshell that element belongs. This is the solution which I already gave you. Now, electronic configuration of cation and anion of representative elements. In representative means metal and non-metal both. For the cation, the positive charge means lose electron. Negative charge means gain electron. Remember that. So whenever you get the positive charge, it means one positive charge, it means one electron loss. If you have two positive charge, it means two electrons loss. If you have one negative, it means one electron gain. If two negative, two electron gain. Remember that, okay? So now look at here, this neon, this is short configuration. Neon has 10. So sodium, oh my god, this is not neon, this is sodium, sorry. So sodium has 11 atomic number, right? So 11 electron, and out of 11 the 10 electrons are here, and first electron is in s1. That is characteristic configuration of sodium, characteristic orbital. Okay, don't miss this one, last one. So 10 plus 1 is 11. So you can write here the one electron is lost minus 1 electron, minus 1 electron, that is plus, you get it. So Na plus means neon. You can write in the bracket only neon because neon has 10 electrons. So this is the way how to write the short configuration of cation and anion. Calcium. Calcium is 20 and argon is 18. So 2 is your characteristic, right? Because calcium is found in second group and fourth shell. 4 means fourth shell. So you can see here this is fourth shell in the periodic table, and this is first row and this is second row. So this you will find here calcium, and here you will find sodium. So in this way you can say that this is first S1, this is 2S2, second one. The characteristic configuration of first group and second group. And now aluminium. Aluminium belongs to third group. This is 13 atomic number. So this is 10, but it is in aluminium in the non-metal side, but it is metal. But this, it contains p orbitals. That's why this is p1. In the p1 you will find. This is the characteristics configuration of aluminium. 3s2, 3p1. Why 3? Because it is a third group. This is third group, third period, third row in the, and now this is first and second row. Now this is start here like this, non-metal, right? Like this. So this is in P1. So this is the first one is, and now here is aluminium, that is 3p1. So you will find in the p orbital the characteristic configuration of aluminium. So if you lose this 3 electron, because the all electrons should remove from the last shell. These are the valence shell. So you have to show all the valence shell in electronic configuration if you write the short configuration. So this is Ca2 plus, this is aluminum 3 plus, this is neon, this is argon, this is again neon. Aluminum 13 minus 3, that is 10. So this is 10, this is 10, this is 18. So atom lose electrons so that the cation has a noble gas outer electronic configuration. So these are the noble gas configuration. As I told you, all metal and non-metal, they want to get the noble gas configuration after releasing electron or after gaining electron. All have neon configuration, because to be stable, because noble gas configuration are the stable configuration. Now anion. Anion means negative. Okay, these are positive. Cation. Negative, see, hydride. This is, we call it hydride because H minus. H never be minus. Only H minus, if it means it receive one electron from metal, only metal. So they will get sodium hydride. So in this case, only the example in which H is minus 1. Otherwise H always plus. H always plus. So the question may be asked in the multiple choice question, which of the following compound has H minus? Okay, so you should know that all metals having H minus, right? All non-metals, they have H plus. All right, now second is this is fluorine, oxygen. These all are non-metal, right? They receive one electron. Now this is 5, so this is 9 now. So 1s2, 2s2, 2p5. This is characteristic configuration of fluorine, right? So you will write here. So total is 5, 7, 8, 9, right? If it receive one electron, become 10. So now this 10, it means this is equivalent to neon. So you can write only Ne in place of F minus. O2 minus. O2 minus, how many electron it receive? 2 electron. To get noble gas configuration, again 10. So you can write neon. This is also again 10. You will write neon. So you understand this? How this cation and anion will have the noble gas configuration? Any point which is not clear, please ask me now. These are important. Hello guys, please ask me any question.
Teach, can you repeat the nitrogen example?
Nitrogen, how many electron?
I don't remember. 7, 14.
7 atomic number, 7 electron. So you have to write 7 electron here. This is configuration, right? 1s2, 2s2, 2p3, right? If it receive, because it is in the third period, it is in the third period, to become 8, how many electron it receive? To become 8.
Just one, teacher.
One electron?
Yeah, one electron, yes. To become 8.
If it receive 1 electron, this become 4. Why this is 6 here? Why this is 6 here? It should be 4 if it is receive 1 electron. I think you forget, I explained very well. For all the carbon, nitrogen, oxygen, fluorine, these are always receive electron to become 8, to become 8, to become 8. If it is third group, now this is third group. So how many electron? It will receive 5 electron to receive 8. This is fourth group and this is second group. How many electron it receives? 6 electron, become 8. This is seventh group. 4, 3, 2, 1. Seventh group. So 1 is here because it received -1. So it is -1 charge. So it receive how many? Plus 7 electron it receive, become 8. I told you like this. Clear now?
Clear.
So this is 3. The 3p means it has only 3 electron in the valence shell. Valence shell is 2, 2. So 3 to 5. So 5 valence shell. 5 electron. And 5 electron you have. So you receive 3 electron here. So that is 3 minus. You will get total is 8. So now 2 here and 6 here. If you add both, become 8. So in the third, wait, I have written something wrong. It is in the third group, sorry, it is in the third group, it has 3 minus, right? So how this will get 3 minus charge? 3 minus, it will receive 3 electron, right? It received 3 electron, so it will get 3 minus charge. But it was in the fifth, sorry, it was in the fifth group. Fourth group, fifth group, sixth group and seventh group. See, this is the mistake. All right. So now this is 5. So this you receive 1 electron. This is the 5 group, right? It received 3 electron to become 8. So now you will get 3 electron. It 6 group. It received 2 electron to become 8. This is 7 group. 6 and 7 group. So you receive only 1 electron to get 8. It is like this. This is very good slide, please memorize this one and this will help you a lot. These all are, look at, these are anion here and this blue color is cation, positive charge. These are anion, negative charge. So see, all cation and anion will either release electron or gain of electron. They will get noble gas configuration. These all are noble gas. These all are noble gas configuration. So this is very good example of metal and non-metal. All right, now next slide, isoelectronic. Isoelectronic means have the same number of electron and hence the same ground state electronic configuration. Same number, either cation or anion, if they have if they have the same number of electron present, that is known as isoelectronic. Iso means same. See, the examples are here. See, this is sodium, right? Cation. So this is having one electron loss. All right. It means become 10 because it's 11 electron. So now 10 you can write here neon because its atomic number is 10. As I explaining, this is this is 13 atomic number. If you release, plus means release, plus means gone, out. So 3 electron out, 3 electron release, then 10 left. So this configuration is neon. All right. Similarly, oxygen, as I explain you, oxygen 8 electron, you will add 2 electron here, so become 10. So 6 plus 4 is 10. This is the valence shell. And now 10, this is also neon because the atomic number is 10. All right. Similarly, this is freon. Fluorine, it receive 1 electron, thus become also 10. Now neon. This is also 10. Now neon. So this all configuration of sodium ion and oxygen anion, fluorine anion and nitrogen anion all are isoelectronic because having the same configuration of electrons. All electrons are same. Is it clear now what are isoelectronic? Anybody can explain any other example other than this? All example I show you before slides, previous one. Tell me please, anybody give me another example for other than this.
Teacher,
Yeah.
can we say
Yeah.
Brom B?
Pardon?
Brom. I think it's Brom or not. In the third group, the first element is B.
Okay.
It lose 3 electrons to become.
Okay.
So we can call it neon as oxygen and
Now how many electron it has? Boron. What is that atomic number?
5.
Atomic number is 5, right? So you will write electronic configuration 1s2, 2s2.
2b1.
All right. So now this is second shell and this is 3 electron. Total is 3 electron and this all electron always remove from the last shell. You cannot remove only one. Remember that.
Yes.
Always from the last shell, whatever electrons you have, they all remove. So now this is 3 plus, you will get it. So now you have 2, 2, 4, 5. If you remove this, then you will get only 1s2. That is helium. So you can write this example here. Okay, so this is very good examples and please go through this. You will always get the question in the exam. Now, when the cation is formed from an atom of transition metal, this is specific now, remember that. In the previous, I already explained the cation only from pure metal, group 1, group 2. Alright, but if the cations are formed from transition metal, so you have to look here, you have to use the concept. What is this concept? The electrons always remove first from ns orbital and then from n-1d orbital. This is I already told you, right? n-1d orbital, because this is configuration for n-1 for d orbital, right? So d orbital always start from fourth shell but 3d, n-1. 4 minus 1 is 3. So we can write here fourth shell and 3d orbital, right? Okay, example iron. Iron you have 26 atomic number, so 26 electron. So when you write down the full configuration, in the last you will get this, because it is the last characteristic configuration. 4s means in the fourth shell and 3d, because this is as I told you, but 6d. The d row is sixth one. So this is configuration for F. E, that is iron. And now this is 18. 18 plus 8, that is 26. So this is short configuration you write. If you want to remove electron, what is written here? You have to remove electron from ns first, then from n minus d, means d orbital. So you remove first 2 electron, because this is shell. This is 2 electron you remove from here, so you will get 0. So you can write here Fe2 plus 4s2 0 3d6. Don't remove electron from d, right? So because the fourth on the up, the last shell, because this is in the third one. Also it is in the fourth shell, but this is 3d, lower than, means close to the nucleus, so it is very difficult to remove. Alright, so now this is, you will write here for argon 18 and only 3d6. The 40 means you remove that. There is no electron here. You already removed 2 electron. Okay, minus 2 electron you remove. And now 3 electron. If you want to remove 3 electron, so 2 first from S and 1 from D. Right? So you will get AR 3D5. So this is the difference. Then minus 3 electron from here, 2 electron from S, and last 1 electron from here. Similarly for manganese. So first of all, you should know that how you will get the question will be given, and write down the correct configuration of Mn2 plus. Okay, so you should know that how you remove electron from which shell. Is it clear, or you want to ask any clarification? This is all about transition metal. So be careful, the transition metals, when you remove electron, you should remove first from S, and then if it is extra electron, you remove from D. Similarly, you will get Fe2 plus, you will get Fe3 plus, you will get chromium 4 plus, you will get vanadium 5 plus, like that. Any question please now? Hello?
No, teacher.
Ask other students. Only one voice I am hearing now. No, the 30 students, nobody tell me. Yes?
No, doctor.
How about fourth
Yeah, please
group?
ask me. Yes. Yes, please. Go ahead.
How about fourth group? Will it
Yeah.
lose or gain electron, or it will stay same?
No. This is your the fourth group, right? This is fourth group in the periodic table. This is transition metal. Suppose this is D1, D2, D3, D4, D5, D6, right? Suppose here. So this is the D6. D6 means The iron is here. You will find iron here in the D6. In the fourth row, D6, but this is 3D, right? So what is your question now?
I mean fourth group like carbon, for example.
I'm talking about transition metal. I'm not talking about the group. I'm talking about the rows. These are rows. These are rows. These are groups. I'm talking about transition metal. I'm not talking about the non-metal. You understand what is transition metal?
Yes, doctor, I get this point, but my question about the fourth group.
Okay. Okay. So what is your question in the fourth group? Tell me the question.
Uh, for other groups, for example, the third group, it shows 3 electrons, right?
Because whatever electron present in the valence shell, that should be removed. So
Yes.
for that, you have to write first electronic configuration, then you check how many valence electron present in the valence shell. That you remove it.
Yes. So fourth group will lose or gain electron.
Both. As I already explained you, it is specific carbon. It may lose 4 electron, it may gain 4 electron. It will make two different compounds. The fourth, this is the carbon here. It will get -4. Also, it will get +4. In this one, this is carbon dioxide, right? So this carbon dioxide is +4 if you calculate here, right? And now CH4, it is 4 plus and that's 4 minus. So this is 4 minus here, -4. And this is here +4 if you calculate charge or oxidation number as I explained. So the different compounds, they have different charges, the carbon only. Is it clear now?
Yes, clear. Thank you.
Yeah, because in CH4, the carbon is -4. In CO2, carbon is +4. So in this way, you can identify. All right, now this see, up to here is the metal is +3. After that, this is -4 and +4. -4 and +4, both. This is carbon. So -4, then -3, then -2, then -1, and then 0. Effective nuclear charge. Effective nuclear charge, one minute. Effective nuclear charge, generally I will just relate it to the plus, right? Related to the proton and electron is minus. So if that is effective nuclear charge, right? I will explain that. Okay, now
Excuse me, teacher, but the screen is black.
uh, 1 minute, 1 minute. I know that it is black.
Okay, sorry.
But I did not start it, right? I'm looking the this one. Effective nuclear charge, I will explain also from the presentation, is designated by Z, right? Capital Z. Effective nuclear charge is symbolized as Z effective, right? Like this. What is actually this? What is nuclear charge? So whatever the protons or electrons you have, there is a repulsion and an attraction between this and bind the electrons with the nucleus that is positive charge. But because of some shells are there, suppose you have this positive nucleus and now this you have the shells. All right, now you have this electron here, electron, 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 right? Suppose you have like this. So what is written here is the net positive charge experienced by electrons, okay, in the multi-electron system. This is multi-electron. Only single electron just you will find in hydrogen, one electron. But if you have any other element in which you have multi-electrons, so that the effective nuclear charge will be affected. Okay, now what is multi-electron atom? The term effective is used because the shielding effect. You know that the shielding effect, just like you have then umbrella, right? I'm very bad in drawing, not like this. Just like umbrella. So if any shower is coming from the cloud, it is protected, right? It is a shielding effect. And also just like the shield you have, right? In the fighting, everybody is using the shield. It protect from any out sources. It protect shield. Okay. So this will follow this effective nuclear charge. It will affect what? Shielding effect. Shielding effect of the negatively charged electron. So what is the shielding effect? Now this is positive. These are the shell. Okay. And now you have this electrons here. You have this electron here. Okay. So the question is how this shielding effect. So this shielding effect is due to the electron. So first I tell you here, this one is valence shell, the last one of last shell, and the first shell, this one is core shell. The first shell just after the nucleus, and this is nucleus. So what happened? This is, you know, electron here in the second shell. This is first shell, this is second shell, this is third shell. So when this third shell created, it is shielded by this electron. They will repel. Negative, 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 repel, not attractive. So this first row is nucleus, is shielded nucleus, right? So the electrons on the second row, they are not able to interact with nucleus. It's very difficult because of these shell. This shell used as a protection. This shell used as a shielding to the nucleus. So the attraction between the second shell electron are very, very less with as compared to the first shell. Now come to the third shell. So the third shell electron also similar. They have the interaction with the nucleus as very, very less due to the shielding effect of first group and second group. These are the two shells, they shielding the third shell. So this is where the interaction between the positive and negative in the third shell is very, very less. So that will experience more effective nuclear charge of the third shell as compared to second and first shell. Point is clear? This is first shell, this is second shell, this is third shell. So these
Actually,
this is just like protection, right? Shielding, shielding, shielding. So this the second and third shell is shielded by the first shell. The third shell shielded by second and first shell. The second shell is shielding by only first shell. Okay, so now shielding.
Doctor,
Yes.
what happens if there is no shielding effect?
No, of course shielding effect is there. Here there is no shielding effect here. Only if you will have only two electrons, helium. No shielding effect. Only one shell. So nuclear charge will be very, very high because more attraction. Clear?
Okay.
All right. Now this the prevent the higher orbitals electrons from the experience the full nuclear charge, experiencing the full nuclear charge by repelling effect of inner layer. Inner layer means core layer. I already explained which one is core. The layer below the valence shell layer, that is core layer. The effective nuclear charge experienced by the outer shell electron, right? Experienced by the outer shell electron is also called core charge. So suppose this also the first shell is core shell, and the second shell also core shell for this. If you have another one, this will also core shell for this. This is 1, 2, 3. This is the fourth shell. So it will be like this. It is possible to determine the strength of the nuclear charge by looking at the oxidation number of the atom. Anyway, so you have to simple calculation nuclear charge. You have to use this formula. Z effective nuclear charge equal to atomic number. This is atomic number. Atomic number. And these are the shielding effect. This is not shielding. Yeah, it will follow the shielding effect because this is core. This is core electron. Core shell or core electron. So remember this. Z is the number of proton in the nucleus, that is atomic number. And S is the average number of electron between the nucleus and the electron in the question, right? See, number of number of non-valence electron means core. What does it mean by non-valence electron? Non-valence means those who are not present in the outer shell. Outer shell, that is valence. Below shell, that is non-valence, means core shell. So you concerned with this S is the core electrons, that is core shell. Now how to calculate? This is an example we have. Fluorine, F minus. First of all, you should know the atomic number is always 9. F minus. So atomic number is 9. So now the electrons are 10 because one electron is added here. Okay. So 9, you have to write here the automatically actual atomic number. Don't write 10 because it contains one electron, but so this become here 10 electron, but it is only original number are only 9 electrons, that is Z. So you have to write the original atomic number here, original number of electron, minus 2 electron. What is this 2? 2 is the core electron. So you have to write electronic configuration of this 1s2, 2s2, 2p, because now this is 10 become 1 electron 11, 10. So now 2p 6. So these are your valence shell, valence electron, and this is your core electron S, 1s2, right? This is last shell. So now you have to remove last shell, thus you consider only this valence core shell only. You have to consider this core shell. How many electron? 2. So now you have to 2 valence core shell electron here, you become 7 plus, right? So that is the nuclear charge 7. Look at neon, 10. So neon, if you write, neon is 10. So now you have the same, but you have to write atomic number 10. Minus 2, so you will get 8 plus. Sodium ion, sodium cation, that is plus, but its atomic number is 11, right? So when you write down the configuration, so you have to write 1s2, 2s2, 2p, 6, 10, and 1 electron loss. So now you will get, this is Na plus, right? When you write down the Z effective nuclear charge, so atomic number is 11, that is original real number. So you have to write equal to 11 minus core electron is still 2. Don't write valence electron. So 11 minus 2, you will get 9 plus. So see here, it is 7 plus, then 8 plus, then 9 plus. So the nuclear charge is increasing. As atomic number increase, nuclear charge increase, right? But the core shell, sometime the core electron will be same. Okay, we have another example. You will write suppose I will write calcium 20. So I will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 6, 8 and 10, 18, 18 plus 2 is 20. So now this is only valence shell. So this is all, these are core shell or electron, core electron. This is valence shell. So you have to be very careful, not only one core shell, because this is fourth, it will be like this. Nucleus 1, 2, 3, 4. This is 4. So now this is 1, 2, 3. These are core shell. So this is number 1 shell, this is second shell, this is third shell. So these are core shell. So you have to count these electron, and when you calculate Z effective equal to atomic number is 20 minus core electron is 18. You will write here 18 equal to 2 plus charge. And generally, as I told you, the all metals, group 1, group 2, group 3, they have the same Z effective nuclear charge as the group number, but only the difference in anion. Okay, now let me finish this one.
Doctor,
Hmm.
I think something. There is nothing appear to us. I think
Hello.
there is nothing appear to us if you are writing something.
Oh, nothing appeared there in the blackboard.
Yes, yes.
He meant
Yes, yes, doctor.
the pen.
1 minute, 1 minute. Yeah, you should tell me before. I have explained everything, and you did
No,
not
just
tell.
tell us for doctor.
Ah,
Stop.
Oh,
This third one.
right. Okay, now I'll go back again, right? Mm, Is this clear to you? This I already explained. It was there or not?
Or just doctor when you writing that on
Like
page.
this one, right? For this example,
Yes, just this one. Yes.
this one example, I am telling you, it has 3 core shell. So whatever electrons are there, you write 3 core electrons, right? In all shells, not third one. So you have to decide first which one is valence shell and which one is core shell. So whatever electrons are present in core shell, you have to write all. So now how you effective, you calculate 20 atomic number original, real atomic number. Don't either cation or anion, whatever you have, but you have to write the original atomic number minus these core electrons. And now core electrons are here 18. So you have to write 18. So you will get 2 plus. So write down the note. Generally, all metals, whether group 1, 2, and 3, they all have the same Z effective as their groups number. Group 1, 1 plus charge. Group 2, 2 plus charge, 2 plus Z effective. Group 3, 3 plus charge, and 3 plus Z effective nuclear charge. All right. So this is all about this. And what is written here, just let me go. Effective nuclear charge on each of the electron. Effective nuclear charge is what? The effective nuclear charge often symbolizes Z effective or Z is the net positive charge experienced by an electron in multi-electron system. The term effective is used because the shielding effect of negatively charged electrons prevent higher orbitals electron from experiencing the full nuclear charge. What is the effective nuclear charge for each? This is we already explained you. For sodium cation, effective nuclear charge varies because each has different atomic number, and the sodium cation has largest effective nuclear charge 9 plus, meaning it has the smallest atomic radius. It means that it has smallest radius, this cation, because of the electrons are removing. So this is the plus 9 plus, you have the nuclear charge, high nuclear charge, because of the electrons, the more attraction. All right. The shielding effect approximated by the effective nuclear charge is due to the inner electron shielding valence electron from the nucleus. Inner electron shielding valence electron. So it means inner electron means core electron. So the valence electron shielded by core electron, you should remember that. So now this is the predictable ionization energy increase with the nuclear charge as we move across the period and decrease as move from the down. We already explained that, but I will come here in the next slide. The ionization energy and atomic orbitals, ionization energy and the atomic radius. So this paper you want to put on the blackboard or no need? This word file, word page, this one.
It's important, teacher. Put it.
Okay, I will put this one, so I will save it. All right, now this already. Oh my God, why I remove? Is already there? No, already there. I thought it is recording is stopped. Okay, so now all right, now I was here. So this is already I explained you what is shielding effect. Anybody can explain shielding effect? In your own words. Don't copy from. Don't read from the slide. Tell me what is shielding effect.
The shielding effect prevents the high the electrons from the last shells to enter to the core.
They will stop the interaction between the last shell electron with the nucleus.
Yes.
So the middle one, which is the shell which is present in the middle, they will act as a shielding effect. It will protect, it will shield. So this is the same, formula is there, Z minus. This, either you will write S or you will write sigma, both designate the core electron. Okay, don't confuse. In sometime in the book you will find sigma, sometime in the different book you will find S. But I think in the chain you will find the S, I think. Let me have this. G packet. In the chain book it is sigma, right? Don't worry. Either sigma or S, you can utilize it both. Okay, it's clear now. I have written here S
Yes, doctor.
or S. See the sodium, magnesium, aluminum, the core electrons are here. Z effective C is going to increase. Z effective nuclear charge is going to increase if you are moving from left to right. If you are moving from left to right, sodium, magnesium, aluminum, silicon. All right, see it is here. Now it is increasing. Effective nuclear charge increasing. Atomic radius increasing. Ionization energy increasing. All are same. Okay, but here, as I told you, in the metal, generally in the metal this also increase. In the metal 1 2 3 4, but left to right is increase. And in cation this also increase, right? Sodium plus 9 and 10 plus 10 plus 11 plus 12, like this. So the atomic radius is indirectly related to the Z effective. As the Z effective increase, the atomic radius decrease. So atomic radius decrease and Z effective or ionization energy increase from left to right. This is left and this is right, and this is top and this is bottom. See, this is another example I have already giving here. You can calculate yourself. I have written here S or sigma. You can write. This is nuclear charge, okay, left to right, and atomic radius, that is decrease from, atomic radius is increase from top to bottom. Atomic radius is decrease from left to right, and also nuclear charge increase from left to right, opposite. Look at here, atomic radius. Atomic radius, see, it will be like this. See, this is going to increase, right? From here to here, going to increase. And from here to here, left to right, is going to decrease. So why it is decrease and why it is increase? Sometime the question may be asked. The atomic radius, why it is increased from left to right and why it is decreased, why it is increased from top to bottom and decreased from left to right. So what is the reason? Here increase, okay, from top to bottom increase. The reason is number of shells are increased. Increase, right? Number of shells are increased like this. It will be like this. But here, it is why it is decreased, because it is the same shell. It is the only same shell. Only one shell. So this is going to be decreased. Why? Because in the positive, the nucleus you have in the center, positive in the center, positive in the center, nucleus. If you add, suppose 2 electron here, it is little bit bigger. If you add 3 electron, then it is attraction are heavier, attraction are more, so this become squeeze, become small. Here is the 4 electron, so also become small. Here is the 5 electron, so more attraction. So the reason is, the question may be asked why it is decreased from left to right. So you can see the reason is because the number of electrons are continuously adding into a single shell. In the first shell only 2 electrons, the second shell 3 electron, 4 electron, 5 electron, 6 electron. So number of electrons are increasing into the shell, means addition. So when number of electrons are increasing, attraction of electron and between nucleus and electrons are more increased and increased. Once the attraction are increased, the size becomes small and small and small. So what is the reason, please? Could you give me why this atomic radius increase from top to bottom and decrease from left to right? In your own words.
It depends upon the number of electrons.
Yeah, addition of number of electron in
the orbitals.
in the single shell, in the only one shell. So as the number of electrons increase, attraction between nucleus and electrons are increased. That gives you what? In order to reduce the size. In order to reduce the size because of more attraction. Less number of electron, less attraction, more number of electron, so more attraction between nucleus positive charge and electron negative charge. Clear this one? And why increase from top to bottom? Because
larger number of electrons in down.
no, large number of electron is
The
okay,
number
but
of cells,
concept.
More shell and
Just only simple answer I have written here. Only number of shells are increased. The shell are increased automatically. Electrons are increased. First shell, second shell, third shell, fourth shell, fifth shell. Understand?
Yeah, more shells, more electrons.
Right. More shell and the size increase. Only in one shell. So the first answer of this question, why from left to right is decrease the atomic size. So you can write here because the attraction between electron and the nucleus are more. That become small, or in order to get the size small, right? More attraction, more small size, become small. You can write any words, any sentence, but because condition is only electron, addition of electron in single shell. That's all.
Doctor.
Yes.
So Rn or R random has the highest number of atomic radius and shells.
See, look at the number is written here: 152, 112, atomic 5, 85, 77, 75, 73, 72, 70. These are atomic radius.
Oh, okay.
And look at from top to bottom, this 265, this is only 152. All right, now how many slides left? 2, 3, 4, 5, 6. Addition energy, affinity. So next time I will take only this. I will finish today. This one, this is a small, no problem. Atomic. This is atomic radius, right? And now, referring to the predictable following atoms in ordered increasing atomic radius. So please, you have to use only things here. This indicate greater, and this symbol indicate less than. This is greater than. So you have to arrange this phosphorus, silicon, and nitrogen. How you arrange? Open the periodic table, please, and follow the rule. The atomic radius increase from left to right, and atomic radius decrease from left to right, increase from top to bottom. You keep that concept in mind and you select which one has greater atomic radius and which one has less atomic radius. Either the phosphorus has, suppose an example I am telling you, but I am not sure it is correct or not. Either it is less, or maybe it is more, or it is less, or maybe it is more, right? Which one is? Or we can write here, maybe it is less than phosphorus, or maybe it is greater than nitrogen. We don't know that. So just you have to go to the periodic table and tell me now, please. Come on, fast.
دكتور السؤال لسه down.
Now I will write phosphorus, silicon, and nitrogen. Which one is greater than? Which one is less than? Between what? Just tell me now and go to the periodic table and tell me one by one.
phosphorus.
Silicon is the greatest.
Silicon is bigger than phosphorus. It means the phosphorus is less than silicon. Same, right?
Yes.
So we can write this like this. Either you can say silicon greater than phosphorus or phosphorus less than silicon. Both are same. Yes. Next. What is the difference between silicon and nitrogen?
Silicon
nitrogen
greater
is
than
smaller than, or silicon is greater than nitrogen.
So nitrogen is smaller than silicon, right?
Yes.
So it means automatically silicon is greater than nitrogen.
Yes.
So we can write this one like this. Okay, I will write another form. As you told me that silicon is greater than phosphorus, and tell me between phosphorus and nitrogen.
Phosphorus
phosphorus
is greater.
greater.
Phosphorus is also greater than what?
Nitrogen.
No,
Sure,
it's
from the table.
less than.
Come on, see the periodic table and tell me.
Less than not.
The phosphorus
than-
low
Equal.
on the
Huh?
bottom of nitrogen.
Okay, now I will check in the periodic table. You told me phosphorus is less than silicon. Okay, phosphorus is less than silicon.
No, teacher.
Silicon.
Phosphorus is greater than nitrogen.
And phosphorus is greater than nitrogen. It's very good. This is correct. And
Yes.
silicon is greater than phosphorus, or phosphorus is less than silicon. So the first one is also correct, right? Phosphorus is less than silicon, or silicon is greater than phosphorus. These both are correct. Now silicon and nitrogen. So silicon and nitrogen. So nitrogen is less than silicon. So nitrogen is less than silicon. So it means silicon is greater than nitrogen. This is also correct, right? Now look at phosphorus and nitrogen. Phosphorus and nitrogen. Phosphorus is greater than nitrogen. So, but now you told me wrong.
Phosphorus equal to nitrogen.
Look at the periodic table. Phosphorus is down and nitrogen is up. So the atomic size increase from top to bottom. So atomic size of phosphorus is greater. Atomic size of phosphorus is greater than nitrogen. And silicon is left to right decrease. So phosphorus is less, silicon is more. So now silicon will be like this. So we can write another one to clarify. Is greater than phosphorus, is greater than nitrogen. Is it clear now? Any
Yes,
question?
Clear.
Yes, go ahead. If any confusion, please ask me.
If I have silicon and phosphor, no, not silicon and phosphor, silicon and
Select any other elements. Okay, I will select now. Oxygen, sulfur, and arsenic. I will select now oxygen, sulfur, and arsenic. Tell me, please.
oxygen is less than.
Right, very good. Oxygen is less than sulfur. Very good. And relation between sulfur and arsenic?
Silver is less than. Yes.
Right. So now this is both are. We can write here sulfur is less than. Sulfur is less than. No, sulfur is greater than. Because top to bottom, so oxygen is less than sulfur. right? Oxygen is here, sulfur is here, so it is top to bottom is increase. So top to come on, top to bottom is increase. It means the oxygen is less than sulfur, atomic size, and sulfur and arsenic. So also sulfur is also less than arsenic, right? And what about oxygen and arsenic and sulfur? So oxygen and arsenic same. Oxygen is less than arsenic. It means arsenic is greater. So we can write another word. Arsenic is greater than oxygen. And now oxygen and sulfur. So oxygen is less than sulfur. Oxygen is less than sulfur. Clear?
Doctor, I have a question.
Yes.
If I have silicon and fluorine, how can I determine?
Yeah, go through periodic table. Yeah, he already gave you all concept.
Yes, I opened.
Okay, check now. Where is chlorine? Where is sulfur? And left, use the concept. Left to right decrease, top to bottom increase. With sulfur and chlorine, so chlorine is less than sulfur. It is on the extreme right.
Fluorine.
Fluorine, okay. Fluorine on the top, sulfur in the bottom. Sulfur is more than fluorine. Class hai. Okay, so now this is you talking about fluorine and fluorine and selenium.
No, silicon. I mean silicon.
Silicon. Okay, so fluorine is on the top and silicon is on the, where is silicon?
Silicon, yellow one, and
Yeah, silicon is here, right? So
Right.
of course it is. You can use this concept. This one. This is bigger. This is small. Clear?
Okay,
Top
now
to
okay.
bottom. All right. Now this is, see, this already done here, but you can also check. I'm not going to remove. I will just save it. I'll already save in the recording. Ionic radius. I was talking about only. What's the time? Is there any time? How many
Yes,
minutes?
we have.
So look at here. Atomic radius. Atomic radius I already done. Then ionic radius. Either cation or anion. Cation radius, suppose I will take sodium or cation. This always is small than sodium atom, right? And chlorine anion always greater than chlorine atom. I'm talking about ionic radius, because why it is like this? Because here there less number of electron, here is more number of electron. So less number, more number of electron will affect the ionic radius. Look at here, the first graph. This is pure, this is the metal, and these are the ions of the metal, right? Cation, positive charge. That's why see the radius is smaller. This is smaller. The metal is large. And now look at the anion. See these are the anion. Negative. This is large. This is only non-metals, pure non-metal, right? So these are small. So now this comparison is clear to you. cation and anion, that is ionic radius. Ionic radius of the cation is always smaller than its pure atom. Ionic radius of the anion is always larger than its pure atom, right? If you compare between cation and anion, this cation size is always less than anion. Any question here?
Clear.
Clear.
Yes, ask any question please. So these are the difference between pure metal and their ions, that is cation, and pure non-metal, that is, and their anion, that is Cl minus, right? Or anything, any anions. The question is, why cations are smaller than anions? Give the reason. So how you explain that?
The electrons.
Yeah, because they have the less number of electron. Because of this, they remove the shell, right? Because the electron you lose the electron, shell remove. But here there is a shell will be same, but electron you added. So because of the more shells in anion, that's why the size of ionic radius is increased as compared to cation. So this type of short questioning, you will get it. Now you can ask any question, please.
No, all is clear.
Alhamdulillah. So now, all right. What is the next? See, cation and I already explained you here. See, the fluorine is anion, and sorry, the fluorine is here, and this is lithium, pure metal. I'm talking about the metal, but not atom. So this always be greater than fluorine atom, not ion. If this become ion, then see cation is less than anion. So this is positive, this is negative, right? So this always less than anion, and this always no anion. This is greater than non-metal. This is metal is greater than non-metal. Fluorine size always I already explained, from left to right the size of the ionic or atomic size decrease. That is explained here. Explanation. Okay, this one and these two and these three. Okay, I will finish this next Wednesday. Okay, let me talk general. I stopped the recording. Okay. Now, after this finishing, chapter 8, your exam will be from chapter 1, 2, 3, 4, 5, 7, 8. No 6. 6 will be teaching in after midterm exam. So remember that. And the question, I don't know, is still not clear, but we already make the exam. But we have not yet decided whether it is the multiple choice online or it is multiple choice on campus with bubble sheet, or it is subjective on campus. I'm still waiting the email from admin. Then inshallah I will let you know on Wednesday. The situation will be clear on Wednesday. Any question, general question do you have?
Thank you, Doctor.
Chapter 1 without us. It's in the mid without us. It's with us. It will be 1 from 1 to 8. Is it or not?
Yeah, 1, 2. No, what I teach in the class. You have the presentation, right? You can check the recording.
I mean, what I want to
Which
in
I
the
covered.
syllabus, it is chapter 1. It's written without us in the mid the syllabus.
Without?
So yes, in the syllabus it's written 2, 8 without 6.
No,
Just 1
no,
1.
I already explained in the class. I already explained from 1 to 6, I think. And from 7 onwards, that will be discussed in the lab. And I already discussed in the lab.
Okay, doctor.
Let me check now. 1 minute. See, from 1 to 1.7. Okay, I already explained in the class, and from 1.8 to and 1.9, 1.6, no, up to 1.6, 1.1 to 1.6 in the theory class, and from 1.7, 1.9 in the lab. I already explained there. Please don't
Okay.
mention like this. In the syllabus, let me check what I have written there. But I already explained in the class. Please don't say like this. Okay. Let me have this. And now, second thing is, I have already put on the blackboard the basic concept of all chapters from one. Let me check here. From chapter 2, right? But one is not here. But you have to just go through the chapter 1, just like heterogeneous, homogeneous mixture, calculation of the thermometer, Celsius to Fahrenheit, something like that, and some example of what is that? The burning of the paper, and I forget the name.
Chemical reaction.
Pardon?
Is it chemical reaction? These stuff.
Yeah, I know this is chemical reaction, but this one.
Physical?
One
Physical.
minute. Just only few things you study, not all in chapter 1. Write down that, please. Chapter 1. State of matter, solid, liquid, gas. Okay, homogeneous, heterogeneous mixture. And yeah, physical and chemical change. So three things, as I told you: physical and chemical change, homogeneous, heterogeneous mixture, solid, liquid, gas. Some multiple choice question maybe you will get, not much. Okay. And chapter review also have for all chapters. If you go through this, look at, please open your website and check now. I already put this practice question chapter all. This is theoretical. And also you have the review chapters recording, because this review chapters I have done last semester. So I think this is good for you. If you can understand well, go through this review chapters. If you don't understand anything, I will explain you the last day, Wednesday, or any other time. It's not necessary, because week 8 you have the exam. Check please now. Go to the course content and check after chapter 8. Just check practice question and review chapters. And tell me now. Right. So one is attachment, that is you open it, and I solve all the questions there, and the brief concept I have written, and also review the chapters. Recording is there. and you can also go through that. All right, all the best. Any question now?
Doctor,
Yes.
will we have same review like review for quiz 1, or it is not necessary?
Reviews are already, I told you now, review already there. If I don't have time, review already there. Review
Oh, okay.
for
Because
all chapters.
yes,
You can go through them.
I meant.
And
Okay, no problem.
I have written very clearly. If you go through the review, you will understand. I know that. And please go through that before coming to the Wednesday. Before coming, go through this. Anything which is not clear, you can ask me on Wednesday. All right. Bye bye.